Well, thank you very much. It's a pleasure to be here today. And as you mentioned, I'm the Vice President of Public Affairs of GSOA, the Global Satellite Association. It's a very interesting and an honor to be here at the EuroDIG opening day. And I think proof of the importance of satellite is that we are opening with this topic this year. Not only because of the innovation that is happening, but how much is impacting the whole ecosystem of telecommunications and how much the collaboration between the technologies is relevant in this matter. Just to give an overview for those that are maybe not very familiar with our association, we are the association that represents the whole industry of satellite. We are led by the CEOs of many of those companies, and we have around members that goes from LEO, MEO, GEOs, and launchers and manufacturers and so on. This is just an overview of our membership. I think today I'm going to just try to share with you a little bit of a holistic view of the satellite industry and where we are today and why all of this is, I think, happening. Just giving a few numbers, we have evolved a lot in what connectivity means, and we have clearly advanced very much, I think, due to the joint effort of the different industries, but also the public sector and definitely ITU and the role that they are playing. However, we still have connectivity in many places, and we have 2.6 billion unconnected. And when we come to talk about IoT and the benefits of IoT, we clearly see a lack in 80% of the world, while a 20%, let's say, benefits from this Internet of Things or connecting the environment itself. So indeed, what is the role of satellite in all of this? I think it's important to understand, and a study that was conducted last year, and with the data that we have, that by 2030, the global economic benefits from SATCOM will exceed $250 billion, but also that more than 500 million people will connect via SATCOM. That means twice as much as today. So indeed, what we are seeing is that there's different capabilities and different qualities of the technologies that can support bridging this digital divide that definitely has an impact in other divides. And so what are the qualities that make satellites so special? And I would say, well, there's coverage, there's reliability, and there's resilience. And those are definitely some of the capacities that satellite bring to the table. So during the last decade, especially, we have seen a huge innovation from the satellite industry in the different orbits and in the different ways of conducting business. I don't think we can talk business as usual anymore, because I think we are taking really a leap into innovation. And this has an impact everywhere, but for sure, and not only, but including rural and remote areas or areas that are underserved or unserved. We live in a moment where connectivity has become, and the demand has grown. We have become increasingly dependent on connectivity, and this means that we are becoming also increasingly dependent on space. So it is essential to recognize the transformative power of satellite technology and how it enables a more inclusive, connected, and digitally advanced society. Today, GSOA members are innovating in space in the different levels, as I said, in the ground, enabling much higher throughput speeds and leveraging the unique advantages. But also, we are very conscious about the fact that no one technology can fit all the problems. And that's why I think we are in a very interesting moment of a mix of technologies with a truly meaning of that. This will allow us to precisely reduce cost and collectively deliver higher resilience and greater access for a much larger number of users around the world. So if we look at that, there is some work that is taking place in 3GPP specifically, in which we have seen how before 4G, because collaboration between satellite and terrestrial networks is not new. There has been work done together for a long time. But before 4G, there was a collaboration. And then when it became with 5G, we started to integrate the concept of satellite in these standards directly. And now looking at 6G and beyond, we are looking at it as more of a unification. So in 3GPP, in release 17, there was a milestone in the sense of, okay, we start integrating this part of the equation, and looking forward to the future, we start thinking about it from the beginning and pulling the strengths of the different technologies from the beginning. So while 5G optimizes terrestrial networks designed to allow the integration of satellite for coverage and availability extension, 6G will optimize this network design, implementation, and operation, considering the characteristics of both terrestrial and satellite communications. So by building on the integration of these non-terrestrial networks into 5G and 6G will leverage the biggest advantages of satellite communication and sensing systems. So we will have different types of 6G devices that will be able to access satellite-based networks with service capabilities suitable for their specific use cases. So the use of satellite systems can help accelerate 6G deployment by encouraging terrestrial telecom operators to use satellite communications. And countries can reduce this way the time lag for the adoption of new technologies between urban and rural populations. This means that they can also begin to enjoy the advantages of a connected population, and the economies will benefit from this and avoid creating an even bigger divide and meet the development goals far sooner than expected. So with the work that is currently going under 6G, it is critical that governments begin to consider the wide range of technologies. For 6G to be socially and economically inclusive, governments and regulators will have to ensure their policies and regulations are also technologically inclusive, so that each technology can play its role in the 6G ecosystem or any future ecosystem. The building blocks for satellite terrestrial integration have been put in place with 5G. And 6G is building on this to deliver the ubiquity, continuity, scalability, and resilience that we're all looking for. So in order for a truly integrated 6G to become a reality, the existing spectrum used by satellite systems must be secure, as well as allowing or providing the access to more spectrum when needed. So what does it mean, all these advancements of the technology inclusion and the 6G or the 5G and so on? One of the mentioning that I also already Thomas has mentioned is the direct to device. So we definitely think that all this integration of technologies has an effect on direct to device as a whole concept that can be either IoT or direct to device as a handset. It is an exciting time, I think, for everyone that uses a mobile phone or is very aware of connectivity, to think about the possibilities that this can bring, not only for current users, but also for many examples and use cases that we think a little bit less about sometimes, but it has a big implication in agriculture systems. It has an implication on the use of the natural resources and how can we better use them through IoT. So to allow to have these IoT services and the D2D services, we need for them to reach their potential, we need to ensure that there is a regulatory framework that enables competition, that we definitely have globally harmonized spectrum, that we foster global and open standards, and that we have a transparent and rational licensing regime. Satellite D2D is and will continue to contribute to bridging digital divides while improving safety of life and opening new horizons for connectivity everywhere. The result is bringing meaningful connectivity to consumers, increased digitalization of services for governments, new business opportunities for enterprises. And definitely there will be different models, and there's different models using a certain spectrum or another spectrum, and there is still a lot of work happening in all this innovation, and I think we need to be open and precisely allowing that environment for the innovation to continue happening. So in conclusion of what do we need for D2D to services to be affordable is that we need to continue working in the 3GPP defined NTN standards, coupled with a regulatory regime that is transparent, that safeguards existing spectrum, and that enables access to additional harmonized spectrum at a worldwide level. So this brings me to the next point that I think it's very important, and precisely is the collaboration. I think something that has increasingly changed during the last few years is the amount of collaboration that exists from both public and private sectors, and also within private sectors. Thomas already mentioned GSMA and GSOA signed a memorandum of understanding to work towards the success of this new innovation, this new integration of technologies. And indeed, we also signed an MOU with ESA, with the European Space Agency, with the same objective of bringing this reality of a network of networks and working together for the same goal, that is connecting everyone and connecting everything. So just as I'm mentioning, and this is not promotion, but the role of the NTN standards in 3GPP was recognized in March as one of the most innovative technologies of the year. And I think this is, again, proof of where are we heading and how important technology is.
We're talking about covering non-served areas everywhere. So how about the fees? Because price for satellite service is quite high right now for regular end users in developing countries. So what's position? Do you have any plans how to make these prices more or less affordable for this audience or for the society? Thanks.
Natalia, question about the trends of pricing satellite services. Could you shortly answer?
Definitely. So I think it is seen as a trend also that the prices of satellite capacity and the prices per megahertz has been dropping also. I think also the integration of the technologies will help precisely that, because it will make a more efficient use of the networks. But also I think it is important that we focus on the framework that we are putting the ecosystem in, so that we can all work together into dropping those prices and not increasing the burden of certain parts or not increasing the burden into the private sector that in many cases can be passed to the consumers.
Okay, I would like to ask you as well, you mentioned main factors for better cooperation and integration between satellite and terrestrial networks, and it was regulatory environment, licensing. Could you describe or highlight maybe a couple of main factors from the perspective of operators between satellite and terrestrial? What will be the main factors for better integration?
So I think the main factors for better integration when it comes to the regulatory part is that we really need to focus on contemplating or fostering this collaboration, for example, between the industries. I know that the sandbox and ways of trying to make this happen in a more pilot base or experimenting base. It is important, I think, and I mentioned the licensing regime. We need to think about how to make these licensing regimes transparent and streamlined, and that, again, it's not creating more of a burden, but it's more facilitating the services that satellites can provide. And in terms of the integration, I think it is very relevant to have more people involved on all the 3GPP's ecosystem, so that we can all contribute to this integration and in a more smoothly and future-looking way.